we've done some different things with piecewise functions in regards to substituting and evaluating. What we're going to look at next is how to graph a piecewise function. So here is an example of a piecewise function, and what we've done with some different things with this has been some things with functional notation in regards to substituting and evaluating. So we haven't really done a whole lot with this as far as a graph goes. So what I'm basically going to get when I graph this is I'm going to get two different pieces to this graph. I'm going to get one that sort of comes from this piece here, and I'm going to get another part of the graph that's going to come from this piece here. And what I'm going to do for each one of these is I'm going to make an XY table. So I'm going to start with just this first piece, 2x plus 3 less than or equal to negative 1. And just keep in mind, we know that since this has a degree of 1, I know that this is going to be a straight line. So I can get away in terms of the number of points that I could use to make this graph. I can get away with 2 points here, and I always want to start. Let me erase this piece here. I forgot to put the x in this here, so let me sort of take this away and get my x value in here. So this is when x is less than or equal to negative 1. So the first point that I always want to put in my XY table is whatever this value is here. So I'm going to put this negative 1 in first. And when I do 2 times negative 1 plus 3, I get positive 1. And that's one of the points that's going to go on the graph. And since in this particular instance x is less than or equal to negative 1, I'm going to put a closed circle on the graph when I do that. So I'm going to have a point that's going to go here, and it's going to be a closed circle because it's x is less than or equal to negative 1. So now I just need one more point, and I can connect those 2 points with a line. So the next number I want to put in for x, and just notice this condition that I have here at the end, I want to pick a number for x that is less than negative 1. So say if I put negative 2 in for x, and if I do 2 times negative 2 plus 3, it's a negative 2. This would be negative 1. So negative 2, negative 1 would be another point. So I'm going to go 2 to the left, down 1. I'm going to put a little point right here. And then all I want to do is I want to take this, and since it's a line, I just want to take the 2 points and connect them. So just notice that I'm not drawing this line through to the right side of that first point that I made, because this is just a line that I'm going to make for values of x that are less than or equal to negative 1. If x is greater than negative 1, that's this function that I'm going to graph here. So let me erase the table here, and I'm going to put this second piece into this. So let me get rid of this here. And I'm going to do the second part of this, which is negative x plus 4 is greater than positive 1. So when I do this piece, negative x plus 4 is when x is greater than positive 1. So this should say negative 1 for these. No, that's not written in there, but that should be a negative 1 when I go to do those. So when I have my XY table here, and that should be a negative 1. So once again, I'm going to put a negative 1 in for x here. So when I put a negative 1 in for x, I have negative 1 plus 4, which when I work that out is going to be positive 5. So I have negative 1, positive 5, which would be a point that's right about here. But remember with this, I should sort of back that up a little bit. Remember with this, because I have x greater than negative 1 and not equal to negative 1, when I go to put this point on the graph, I actually want to make it an open circle and not a closed circle. So I got 1, 2, 3, 4. So I want to go open circle here instead of a closed circle. And that's basically just to sort of symbolize that this is not, x does not equal -1 for negative x plus 4. So that's where the open circle comes from. So now I want to get one more point, because once again, this piece of the graph is also a straight line since it's has a degree of 1. So when I go to put another number in for x, I want to make this value greater than -1. So I'm going to put a 0 in here. And when I put a 0 in here, the answer to this is positive 4. So 0, 4 would be another point on the graph, which would be right about here. And then all I want to do, once again, is just connect those 2 points with a line. So I'm going to get something that kind of looks like this. And that is the 2 pieces of this graph here. So one of the things that I wanted to show you with each one of these graphs was how you can use your calculator to check these. So if I come back to the step function, the greatest integer function that we had, greatest integer function of x plus 1. If you take your calculators and you go to y equals, let me sort of clear this out here, and you go to math, and you go to number, and you go to number 5, and where it says integer, that's the greatest integer function. So if I put an x in there, and then I do a plus 1 at the end, and then let me zoom 6 this, you get something that looks like this here. So one of the things that your calculator is not going to draw for you when you do this is it's not going to have for you on here which side of the segments are closed circles, which side are the open circles. So you're going to have to know that from the original graph, which is what this sort of says here. So that's basically the one piece. And then if we look at the other example of the piecewise function. So in terms of putting this into your calculator, it's a little bit of a sort of a weird looking thing that you're going to have to do here. So if you take the first piece, 2x plus 3 is less than or equal to 1. If I go to y equals, I want to put first the function in parentheses, 2x plus 3. And then I want to put after that in its own parentheses the condition. X is, to get the less than or equal to sign, you have to put second and then math, which is the test screen. So I want to put in a 6 here for less than or equal to -1. And then plus, and then I'm going to put the second piece to this in, which is -x plus 4 is greater than 1. So I'm going to put in its own parentheses the function -x plus 4, and then the condition after that. So I got in its own parentheses, x is second math, greater than is 3. I'm going to put a -1 at the end there. And when I graph this, here's what you get. So keep in mind, similar to what I showed you with the step function in regards to your calculator, it's not going to give you open circles, closed circles on your graphs here. That's something you're going to have to know what to do with those based on the condition that it gives at the end of each function, but kind of gives you a pretty good indicator in terms of what your graph looks like and things like that. So that's basically how you use your calculator to do each one of those different types